Hello and welcome to another episode of the Sense Think Act podcast, a show where we delve into all areas of robotics, exploring the fascinating world of machines that sense, think, and act. I'm your host, Audrow Nash. Today we have a very special guest joining us, Louise Poubel, a renowned figure in the world of robotics and the former lead of the Gazebo project. Louise is currently the simulation lead at Zipline, a company revolutionizing healthcare delivery with drones. In our conversation, we'll be delving into the intricacies of Gazebo, an open source 3D robotic simulator, comparing it to other simulators, and exploring the team's effort to make Gazebo more accessible to beginners. We'll also be discussing the role of simulation in machine learning and reinforcement learning, the challenges in the simulation space, and how simulation can be used with physical robots. Louise will be sharing her insights on the future of robotics, the importance of open source projects, and the lessons she's learned from her experiences. Whether you're a robotics professional, an enthusiast, or simply curious about the intersection of simulation and robotics, this episode promises to be enlightening. Thank you to our founding sponsor, Open Robotics, and without further ado, let's dive into our conversation with Louise Poubel. Would you introduce yourself?
Hi, Audrow. Yeah, thank you for having me here. My name is Louise Poubel. I'm currently the Gazebo technical lead at Open Robotics.
Mm-hmm. And let's start at the beginning, sort of. How did you get into this position of Gazebo technical lead?
Yeah, so it's been a while. I've been at Open Robotics, involved with Open Robotics for almost 9 years. I started as an intern through a remote program that was sponsored by the NOM Foundation at the time, and it was called Outreach Program for Women. Nowadays, it's called Outreachy because they expanded to other minorities besides women. But it started like that. It was a remote internship. I was working from like just from the internet back before remote work was a thing, and then became a contractor for Open Robotics to continue working on my internship, and eventually became a full-time employee and moved to the US to the headquarters where Open Robotics is located.
Mm-hmm. Okay. And then how'd you get started with Gazebo?
Yeah, so like my internship was with the Gazebo's web interface that was on like that's back when for on Gazebo Classic, which is the older version of Gazebo. So it has a web interface, and my internship was to make it available on mobile phones. So you open a browser on your phone, you can have like touch controls for the interface. So it was very nice. I knew nothing about Gazebo at the time, or about robot simulation or even programming, because I did mechanical engineering. I'm a mechanical engineer. So everything was new, and it was super fun. So I just wanted to keep doing more of that. Yeah. And then eventually when I joined, I became a team member of the Gazebo team, and then moved more to C++ programming because my internship had been JavaScript. And then I had to learn C++ on the job, and the entire team was like amazing. Like I think it was a great way of learning with the open source community, just everything in the open. Like pretty much all of the code that I've written in my entire career is open source, and anyone can look at and see like the earlier code that I wrote and the mistakes that I made. You can see the whole trajectory. Yeah. And eventually, like a few years ago, I ended up becoming the lead of the Gazebo team, and that's where we are today.
Yes. Now, would you talk kind of broadly about what Gazebo is? And then maybe we can get into kind of like the different permutations of it with its different versioning and the naming and everything after that.
Yeah, sure. So Gazebo is a robot simulator. It's meant to be very generic, so it doesn't specialize in a specific type of robot or application of robotics. So it can simulate everything from robots in space, underground, flying, underwater. It's very generic in that sense. And it pretty much has the physics side of it that does the rigid body dynamics calculations for how bodies move in space, how they collide with each other, how they respond to forces like gravity. And then it also generates a lot of synthetic data for your your robot. So it's pretty much a robot simulator. The idea is to be a virtual copy of physical robots that you have or that you're planning to create, and it should have all of the same features as your physical robot. So it will have like your physical robot will have like your podcast is called Sense Think Act, right? Like it has to sense things, and all of these things that it senses from the real world, we have to fake them inside the simulator. And then the thinking part is the part that is the logic that you would put in the physical robot, and it has to behave the same way in the simulated robot. And then the act part is the part of like how the robot moves in the world, how does it interact with objects, how does it collide with them, and so on. So that's pretty much what a simulator is. And Gazebo is one of many robot simulators that exist out there. It's been around for over a decade, for a long time. And it's widely used together with ROS because Open Robotics, where I work and we work, we maintain both Gazebo and ROS. So they are very closely related, and they work very well together.
Now, you mentioned Gazebo Classic, and just how do all the names go? And I know we went to Ignition, and now we're back to Gazebo. Can you tell me about all that?
Yeah, so Gazebo, as I said, the project has been around for a long time. So we've had several versions, right, that we make releases and we make them available to users, and we make improvements and release those improvements. So the older code base, with the classic code base, it is what we refer to as Gazebo Classic, was released from version 1 up to version 11. And we still maintain versions 9 and 11. They have a 5-year length of support. So Gazebo 11 is still going to be around until the end of 2025 or the beginning of 2025. And so that's a code base that is the older one, but it's still very active. People are still contributing to it. Open Robotics is not putting active development time into it, but it's still pretty much alive and supported. And that's based on an older code base that is, of course, open source. And then to improve several things with that simulator several of its shortcomings, we decided to break it apart into several libraries that can be used independently. They can be used by other projects, because there was a lot of useful codes that was kind of siloed inside Gazebo, and other people wanted to leverage it for their projects. They had to kind of copy it. So we decided to break everything apart into various libraries, which are pretty much little packages that you can use to build other pieces of software. And then in this process of refactoring, as we call, like reorganizing the code, we decided to call everything Ignition. So we have Ignition Math, Ignition Physics, Ignition Rendering. We split all of these parts into these smaller packages. And then coming to this year, so this happened like, I believe it's like 2014 or so. It's almost a decade also, like the Ignition side of the project is the beginnings of it were with Ignition Math. So for example, inside Gazebo Classic right now, you don't have a hard-coded like math library inside of Gazebo. It actually picks up this other library, this other package that is Gazebo Math. So we named everything to Ignition, and then we had a little problem with copyright with the name more recently, and we decided, okay, let's go back to the good old Gazebo name that everybody loves. And there was a lot of confusion too inside the community, like what's Gazebo, what's Ignition, and when should I use one or the other? So now I think we have a more coherent story of we had Gazebo Classic, which was this older code base. It has versions from 1 to 11. And after that, we have the named Gazebo releases, which are the later ones, which instead of numbers, we use names, and they are alphabetically ordered, very similar to the ROS release style. So it's a Gazebo Acropolis blueprint, and all of the names are architecture themed, and we ask for the community to help us with the naming and so on, very similar to ROS. So like right now, the latest release is Gazebo Fortress. So it's F. It's already 6 major releases that we've made of the new code base that is more modular and so on. That's a brief story.
So it was Gazebo, then it became Ignition Gazebo, then there was a copyright issue, and now it's Gazebo again. But the old Gazebo we refer to as Gazebo Classic. So Gazebo Classic is 9 and 11, and Gazebo is now these ones that have letters, like Fortress. And so that's all right?
Yeah, that's correct. Hopefully it's not too confusing.
It's Gazebo Classic, that's the older one, and Gazebo is the new one that was formerly known as Ignition. Okay, that's clear by me. And so you have an upcoming release also for Gazebo. Tell me about that one.
Yeah, sure. Well, by the time this podcast comes out, it's probably going to be released already. It's Gazebo Garden. It's the 7th major release. And it's going to be the first release where it's Gazebo native with the name back to, because from Acropolis all the way through Fortress, the very first release we use the Ignition name. And now we are going back and making the Gazebo name also available for those versions that we support, so people can start using the new name. But Garden's going to be the first one that is native, like Gazebo. So everything from namespaces in the code, the names of the libraries that you install, nothing will be Ignition anymore. It's actually like we decided to go with GZ, which is shorter than Gazebo. The name of the project is still Gazebo, but everything in the code, it's GZ. So it's easier to type.
Gotcha. What are some other, like, I assume that the renaming is not the only thing that's different. Can you tell me kind of like where are we at in terms of the simulator for this version?
Sure, yeah. So every release we make, it comes with a lot of features. It's important to point out that we do add features to the older versions that we still support. So the one that I'm wearing, the shirt right now, Citadel, is the oldest version that we still support. And we are actively adding features to it all the time. So if you're on Citadel, you can benefit from bug fixes and new features as long as they don't break anything. But whenever we add a feature that is not going to be compatible with what's already there in a stable release, we push that to the upcoming release. So that's Garden right now. It's our current upcoming release. Or it's going to be very fresh by the time people are listening to this. And some of the new things that we have in Garden that you can't find on the previous releases are things like that I'm very excited about is, for example, you can have support for lunar surfaces, like lunar terrain, and with all of the proper like dimensions and the proper coordinates, because so people can simulate robots on the moon. And also like we made it general enough that you could simulate robots in other celestial bodies. So until now, until Fortress, you can only do pretty much Earth. You can kind of hack your way around for the other ones, but for Garden we have native support for the moon, for example. Yeah.
So I'm imagining you, like the things, you change the gravity, maybe you change the what the sky looks like, or you change, like what kind of things are included when you have like with lunar surfaces or simulating on the moon? Like,
Yeah, so for example, there is this format called Digital Elevation Maps, DEMs, which is a format that you describe terrain and you can load it into various different software. So Gazebo supports, from Gazebo Garden, we support that format DEM, and it's one of the formats that you can download lunar surfaces, like actual, like the bumps and mountains and exactly as that terrain looks like in the moon, and you can import that into Gazebo right now, and they are going to be geolocated properly. They, like when your robot moves 1 meter ahead, it's going to be exactly the same measure as if it was moving 1 meter ahead on the moon, right? Everything is perfectly placed right now.
gotcha. So very close integration with this other format that is used often in defining terrain that we see on the moon, this kind of thing.
Yeah, and people use it to define terrain on Earth too, and it's generic, right?
Yeah, it's probably just very flexible. Like I imagine you want to describe like cavities or some sort of complex rocks or whatever it might be, and maybe you can do this well with the DEM format. Okay. So lunar surfaces. So that's one of the big changes that you're very excited about. Are there other ones?
Yeah, there's a bunch of stuff. Like, for example, one of them is a lot of new camera features like fisheye camera. The cameras with distortions are available there. Also related to the rendering side, for like some people who are using simulation really care about the rendering fidelity, and they want to simulate a lot of different visual phenomena. And up until Fortress, it wasn't very easy for you to customize certain visual aspects of the simulation. And from Garden, we have support for people to write their own custom shaders, which is a type of program that you run for the graphics that runs in your graphics card. And it allows you to do a lot of things, for example, like moving waves in simulation, which we didn't have up to Fortress. Everything was pretty much very solid, right? Like you could move blocks of things, but you couldn't have like effects of anything that you want to make it shiny, any visual effects. Like shaders are pretty much are very powerful, right? Of course, you have to know how to write a shader, but you can also get like you start from a lot of things that you find on the internet. So,
Can you tell me? I don't know very much about shaders. Can you tell me about kind of like at a fundamental level how they work and kind of like
I'm not a rendering expert. Yeah, I can tell you that it's very low level. You're acting on the vertices and like you're pretty much telling your graphics card how to draw vertices, how to draw normals, and all of that on the screen. And you can do some pretty neat like animation kind of things. Like one of the things that we have coming up in our demo is a flag that is just waving, right? It's going to be a purely rendering thing. If you try to collide with that flag, the physics is not going to be colliding with that. But it's just like tweaking the visual aspect of things. You can do things like bloom effects, which is when when a camera turns to the sun and you kind of have like that little spot of light. These kinds of effects are things that you can simulate using custom shaders.
mm, that's really cool. Okay. So custom shaders that so you can get really sophisticated rendering of different phenomena with those custom shaders. How do they work? How do they take in like state of the environment? So if it's like I'm trying to get that little light flare that you get in cameras when the camera turns towards the sun, how would it? How would you make it aware of? Like how do you give that information to a shader to show?
Yeah, I believe so. I've only modified shaders. I've never written a shader from scratch, but I believe that you have variables for example, the point of view of where you're looking for from, right? Like so, in that case, you would say, well, I'm in this. The camera that is looking is in a certain position. The light that is the light source is in another position, and based on these two positions and some characteristics of the light and some characteristics of the lens of the camera that is looking, you would generate that lens flare, and then when the camera moves, that position changes, and you are able to calculate how that flare would move there.
That's super cool. I'm imagining like you basically say these types of objects have a relationship, and that's going to define some math relationship of what you should express on the screen. So maybe it's like the sun is one of the objects, and it sends out these rays, and anytime those rays are going to hit my point of view camera, then it's going to perform some operation. Like it runs it through a function. The function says there'll be a little circle of light here.
I believe so. Yeah, yeah. I also like I am not a rendering expert, so.
Gotcha. Okay. Anything else you're very excited about for this release, or?
Well, there's a lot of little things here and there. Like we are supporting more mesh formats. One of them is GLTF, which is people who do game development are very familiar with. And there is a bunch of resources online in that format. So now it's much easier for you to load them into Gazebo. Before this, you would have to convert them from from that to another format that Gazebo understands, and you would lose some of it, and some other formats are less efficient because GLTF you can load it as a binary, which is very efficient in memory. You don't have to be parsing like a text, for example. So we are also improving like our support for the bullet physics engine, which is an alternative to our default physics engine, which is called Dart. And yeah, various things here and there. Also, like we are gonna, like in the past year, we've added like support for tracked vehicles, and that's actually available from previous versions. But it's something that we're going to be highlighting as part of the Garden release because it's new, right? Even though you can use it from Fortress, it's something that came out during the Garden development cycle.
Hmm. How do you guys pick what to work on? I'm familiar with I'm a lot more on the ROS2 team in Open Robotics than the Gazebo team. And so we have, when there's a new release, we prioritize different tasks that we think need to be done, different features, maybe think of a theme, this kind of thing, and then try to work with that given the time that we have available. Um, do you do something similar, or how do you prioritize what features should be in a new release, or how do you work with the robotics community to figure out what those features are?
Yeah, so Gazebo has like it, compared to Ross, we have a much smaller community of external contributors, right? We do have people actively adding features and making contributions to Gazebo, but the bulk of them comes from open robotics developers. And those contributions come pretty much from our open robotics clients. That's open robotics business model. We offer R&D services to companies and government folks who are interested in using simulation, and if they want any improvements to the simulator for their specific case, then we make them, and we also happen to make them available to everybody else. So that customer gets the benefit and everybody else does. So a lot of our roadmap is driven by what people in the general robotics community are needing, because they come to us and they say, well, I'm developing this product. I really need this feature. Can you develop it for me? And it goes from there. And then a small chunk is what we call like internal development that Open Robotics puts its own development time into to add features. And we for the Gazebo team, we have quarterly themes. So the theme for this quarter, for example, or actually we've been doing them for half years. So for the second half of 2022, it's quality assurance. So we noticed that like sometimes we make our releases and there are regressions, or people open pull requests that break other things. So we were thinking, okay, what are things that we can do to improve that and improve the product that we are giving to people, right? So we've been doing a lot of things like writing more tests, improving our test coverage. But the goal for the focus for the previous semester was out of box experience. So we did like we added, did various tweaks to the UI so that it was easier to use. A lot of like keyboard controls for the menus. We have like now, if you open the latest versions of Gazebo, you just don't choose any specific environment to open, like you just open Gazebo, you have now a quick start dialog that shows you some example worlds that you can start from. And because before people would just download Gazebo, open Gazebo, and there's nothing there, and it wasn't very clear. Like that first contact with Gazebo wasn't the nicest one. So we put a lot of effort into this. So every month, every quarter, we kind of try to focus on something different that we think none of our clients are paying for, but we still think it's very important for the community, and we put the internal funds towards that.
Hmm. Gotcha. I really like that. I like these smaller sections, like the semesters, as you're calling them, of things to focus on to improve the experience. And you talk with the community, or how do you figure out what these internal semesters should be dedicated to?
So far, it's usually like we sit together, the internal to Open Robotics together with like we get together like with the ROS lead, with the infrastructure lead, with other leads of other projects inside Open Robotics, look into what is coming from clients, look into what we've seen that is being asked from the community. So we don't have, for Gazebo, we haven't like opened it for the community and to do a vote or anything like this. We definitely look at into like what are issues on GitHub that people have voted on. If there is something that is very like desired, for example, GPS was one of them that no clients were asking for GPS on Gazebo, but we heard a lot of people in the community saying, well, you know, I need GPS on my robot, while the like as long as the new Gazebo doesn't have GPS, I can't use that. So we put some internal funds into getting GPS moving and getting GPS support into Gazebo. So we listen a lot to the community. We are always looking into GitHub issues and trying to find the gaps on what we think Gazebo needs and what no specific clients are paying for.
Hmm. Yeah, I really like that. Being well connected to the community seems like a really good thing because we do have the clients and the clients pay for specific things, but like the community, maybe it's a bunch of students or it's a bunch of earlier startups that aren't working with us and they're saying, oh, we really need GPS or something. Like that's really nice that then we can meet their needs and be their, I don't know, the simulator they use for these, for whatever they're trying to simulate.
Yeah. And from a business perspective, it's also good because then now we have more users and we have more potential customers now that maybe they never looked at Gazebo because it didn't have GPS or some other feature. But now that it has, the gap is smaller for them to get their own uh, product simulated into Gazebo, and now they are willing to use it and bridge that gap. So.
Yes. And this may be a loaded question, um, and I know you're biased, but how does Gazebo compare to other simulators that are out there?
So I haven't. Yeah, I'm definitely biased, and I don't have a whole lot of experience with other simulators. I've touched various other simulators over time, but I definitely haven't touched any of them as much as I've touched Gazebo. So it's really hard to tell. One thing that I do see that Gazebo is doing that nobody else is doing is the level of customizability that we offer to users. So most simulators, you're stuck with one physics engine. And then if their physics engine doesn't have the feature, doesn't fundamentally can't solve the problem that you're trying to simulate, you just can't use that simulator. With Gazebo, we have an abstract interface that you can plug in any physics engine that you want. Of course, given some constraints, right? It has to be on C++ usually. You have to have some certain hooks there in the physics engine, but in theory, it's extensible to anything that you may want. So this degree of customizability is not only on the physics, but it's also on the rendering. It's also on the graphical interface. So we really, as we went from Gazebo Classic to the new Gazebo, we really made it extremely flexible. So you really only pay for what you use, right? Like you pay in with resources in your computer, not with money. Everything's free, but you can. When you're loading the simulation, if there are things that you're not interested in simulating, like if you're not using a GPS, you just don't load the GPS code and it makes your simulation faster. Things like that. So it's extremely customizable. And I think that this is something that is really valued, especially not maybe the beginners, like people who are in academia just starting. They don't really have a need for using anything besides the default, but it's very common for companies to have, they are simulating this very specific phenomena. They already have their like physics figured out, but they don't have any of the other tooling that we have in Gazebo to visualize it, to introspect it, to record and play back, to see it on the web. And for them, it's very valuable to just come, plug in their little physics piece that is very specialized, and leverage the entire rest of the ecosystem. Right.
Hmm. Yeah, for sure. And I imagine, especially, so Ross, to me, and I'm biased, seems to be a very large part of the robotics community. And so working really well with Ross, being that we're at the same company and we talk all the time and things like this, even though like I'm not very knowledgeable about the Gazebo side of things, I imagine that's probably a pretty big advantage too. Even though I know other simulators like Unity, for example, seems to support Ross, although I haven't played around with it very much.
Yeah, yeah, like you said, the ROS community is so large that like pretty much all of the big simulators nowadays have to have good ROS integration. I don't think that this is a thing that a big simulator would skip nowadays, but it's a requirement. Yeah, but one advantage that we do have is that because the development is done so closely, a lot of the concepts that you find in Gazebo are already gross concepts. Like we have publishers and subscribers, and a lot of it is an extension of what you would experience as a ROS user, and I think that makes the learning curve much lower. Like the way of installing, the platforms that we are available on, it's all very close to ROS compared to other simulators, I think.
Which are entirely separate ecosystems with entirely different paradigms, you mean?
Yeah, yeah, I think so.
Gotcha. One thing that you were saying that sounds really smart, where it's like you can turn off, like if you're not using the GPS, you just turn it off so you're not wasting resources on that. It sounds like with the new Gazebo, the plugin architecture is really like something you guys have relied upon heavily or leaned on heavily.
Definitely. Gazebo Classic already had a lot of plugin interfaces. Like you can write a lot of custom code without needing to change the core of the simulator. You just download Gazebo, then you write your own piece of software that when you launch the simulation, they run together and they do something different that other people who have Gazebo don't do because they don't have your own plugin, right? That's pretty much what a plugin is. For when we migrated from Gazebo Classic to the new Gazebo, very modular, we took that to the next level by like making, yeah, it's so much abstraction that you get there. Like there's so much customizability that you can do. You can just, there's abstraction in the level of the libraries. Like you can use just our graphical interface libraries to do another application that is not even a simulator, right? Like you can just, and people have been developing like you know other usually robotic software that just uses our graphical interface and our rendering. On the other end of the spectrum, there are people who just use our model description, like how do you describe the world, how do you save that to a file. All of that is also isolated, so you can use that without using the core of the simulation. And there potentially there could be people just using the physics part and so on. And each one of these also has like the plugin interface for the rendering. You can use a ray tracing engine, or you can use, which is a very like modern, very high fidelity rendering, which usually runs a little bit slower, but you can use that. And you can also use a slower but a faster but less like nicely looking rendering engine. You can combine the two. You can have one for the user interface, one for the what you as a user is seeing, and one use a different one for what your robot is seeing. You can combine them like that. So it's very customizable for sure. And I think that like that's one of the things of being open source. You can never know who are all of the people who are using your software, because they can just take it and go and don't tell you anything about it. But I really look forward to seeing more and more different projects leveraging this flexibility of Gazebo to integrate like various different engines in the physics side and the rendering side, creating a lot of different plugins that modify the behavior of the simulation, different graphical interfaces. All of this is customizable. I already see some of them in the wild, just run into things, people suddenly using Gazebo in a different way that I hadn't seen before. But I'm really looking forward to seeing more and more of that.
Huh. Yeah, one thing that I really liked, and it was before I came to or before I started working at Open Robotics, I think I saw a presentation you gave on YouTube where you used Gazebo as like a slideshow thing. So it would like jump from one spot to another and it would zoom all around, this kind of thing. You go run up to your slide image and then run up to the next one, this kind of thing.
Yeah, that's just a custom plugin that I wrote, and it's available on GitHub, but it's not core part of Gazebo, right? It's just one example of a weird thing you can make a simulator do. Yeah.
Yeah, it's so interesting. It's like it's good for just general visualization, and you've made it so flexible that you can make it a big, beautiful PowerPoint stand-in, which is just wonderful. For that, did you like export each slide as an image and then put them in locations and then make the camera pan up to them, or was there like a more sophisticated way of connecting the slide to the location that it was displayed in?
Oh, I've had so many, like every new presentation that I give, I tweak and I add new features to my little plugin. But in essence, it is, I make slides as a PDF, and then I export that PDF to PNG images, and I use them to texture various boxes, and I just place them all around a 3D simulated world. And then my script, like there are many different things that you can do. You can just have, I call them keyframes. You can have the camera move to a specific position in the world to look at the robot, for example. If you're in the middle of your presentation, you want to see the robot doing something. You move the camera there and you can send some commands to the robot and it does something. Or you can move to look at one of the slides. And then even if they've moved in the world, they're boxes, they have physics, they can move. Even if they moved, your keyframe will still go and look at it, position the camera to look at it in a way that you can see all of it. There are other things too, like, you can record a log file, then you can play it back as your presentation. We used this in one of my Roscoe presentations in the past. So every time you go to that keyframe, the robot is doing the same movement there, and you can play that back and you can go back and forth, and it's always like doing the same thing.
That's so cool. Now, with it being so flexible, how do you balance ease of use? You were saying that like out of the box experience is a thing, was a focus for the past. How do you make something so flexible and so powerful, something that users can kind of get their hands on?
Yeah, that's difficult, right? Like finding the right balance, because you want the features to be there for the power users, but you also want the defaults to be good enough for the beginner that doesn't know how to turn all the knobs to just be able to launch the simulator and do something with it, something valuable with it from the start, right? With very little configuration. I think that the very first versions of this new Gazebo, like Acropolis Blueprint, it was very complicated, like for example, like physics is optional on the new Gazebo, right? So it was very easy for you to just launch a simulation and nothing moves because physics was unloaded, and there are use cases for that. You not always need the physics, but we recognize that of the beginner user, the person who is going to the simulator for the first time, most likely they want the physics, right? So we started like loading a set of plugins by default, so that you get physics by default, and then we make it harder to do the power user, right? The power user needs to do extra configuration to turn that off, but the default behavior is to have the most common, most useful things loaded. Yeah, I don't think that I'm not claiming that Gazebo is like the most usable, beginner friendly one right now, but we did a good push during the past couple of months to really improve the out of box experience and make like the first contact much more easy. And there's definitely work to be continued there.
Mm-hmm. And then also, I think you guys have put a good bit of effort in the documentation.
Yeah. We always try to make sure that every new feature has at least a little tutorial accompanying it, or an example world. Like compared to Gazebo Classic, the new Gazebo has like at least 100 example worlds. So if you add any like a small feature, we make sure that there is a little world that is installed with Gazebo that you can load it, and now you can load it from the quick start dialog. That demonstrates the bare minimum that you need for that little feature to be exercised. So for example, we recently added a plugin that applies a force to anything in the world, right? Like just pokes something, right, and pushes it in the simulation. So there is an example world that shows you exactly the plugins that you need to load, and it has like some comments there that you can see, like if you send this command on the command line, if you run it, it's going to actually apply the force again and keep applying it, and this is how you can configure the direction of the force. And that's a very simple world just with a box that you can poke around. So if you need to push your robot, you just delete that box, put your robot instead there, and then you're ready to start pushing your robot. Yeah.
That's funny. Yeah. I'm just imagining like the robot gets stuck. You just like nudge it a little bit.
That's something that people do in real life, right? Like people are always pushing robots to see how they react. So you can do that in simulation too.
Yeah, yeah, with like Boston Dynamics when they like kick Spot over and
Yeah.
this kind of thing.
Yeah.
That's so funny. So you could do that in simulation too. Wonderful.
Right? Yeah. Your leg is not going to show there like kicking the robot, but the forces that it's going to feel are the same.
That's crazy. Okay. Let's see. So I'd like to back up just a little bit. You said generic simulator. Can you get into that more? How does it compare to a specific simulator, and then how did you make it generic?
Yeah, so people may be familiar with, for example, flight simulators, or there are simulators that are made specifically for self-driving cars, and they are very good at one thing, right? Like all of their features. Like if you try to get a flight simulator and you try to simulate a self-driving car, you're not going to be able to, because it makes assumptions about the things that it's simulating. They're always going to, have 6 degrees of freedom in the environment. They are not going to have a whole lot of joints. They're not going to have like wheels rolling and things like that. So on Gazebo, we try to make it as generic as possible. And this is like one of our guiding principles in Gazebo's development. We have them listed on our site. And the very first one is like Gazebo is generic, right? Like we're not going to add a feature, for example, to the physics that makes it very good for one case, but unusable for another one. If you really need a feature that is not generic, you can always throw away your physics and write your own physics, because it's all pluggable and modular, right? So you have the flexibility to customize it, but the core and the things that we release as the Gazebo team, we will always go for the more generic approach.
Mm-hmm. That makes sense. Yeah, so that's a cool approach. So basically, you make it so that Gazebo is flexible enough, and there are certain parts that you just need in a simulator. You need a physics engine, you need a renderer. Um, or I suppose for most cases, I guess you said you could get away without a physics simulation or physics thing if you just want to do like an RViz kind of thing or have floating things or whatever it might be. But in most cases, you have these, and you've made it so that you make each of these, well, generic enough so that they're useful if you want to simulate a robot picking something up or driving around or doing whatever else. But then because of the plugin architecture, you make it so that if someone says, oh, I need this one particular thing, I need really accurate contact physics, for example, then I'm going to replace your physics engine or maybe a part of the physics engine or some plugin or something so that I can choose how the physics are being handled. And then that makes it so I can tailor the simulator to my specific case. So it's like good overall, and you can alter what is not meeting your requirements.
Yeah, correct. I can give you a concrete example of a project that I've been working on recently. So, for example, Gazebo, the physics engine, it has been designed with the goal of working in air. So, robot is moving in air, and when you're moving in water, or even when you're moving in air with a vehicle that is very light, like the density of the vehicle, like a balloon, is comparable to the surrounding fluid, which is air or water. There are some physical phenomena that Gazebo currently doesn't simulate very well. So people who are in maritime are really worried about this. They really want for their simulations to be more accurate. They have to take that into account, that when you're moving in water, you're dislocating all of that fluid around you, and you have to take that into account. So we are right now in the process of seeing if we can modify, like add to the existing physics engine so it can also simulate that. But by default, it doesn't do that extra calculation for that because most people using it wouldn't want it, right? You don't want to make that the default, but you want to make that possible. And it's very possible that the physics engine may not be able to simulate that, and we will have to just strip away that physics engine and plug in a specific engine written for maritime purposes that takes that fluid into account. So that's an example of like a very specific application that needs us to simulate a specific phenomena, and you don't need to change how everybody else is doing their simulation. You may just be able to change it for your use case.
Yeah, that sounds great. That the flexibility is really nice there, and that probably makes it so like as a roboticist, I can learn Gazebo as like one set of tools, and then I can apply it to wherever my career takes me, wherever it goes. This kind of thing, because it's flexible enough that once you learn it, like you can make PowerPoint presentations in it. That's just I thought that was so funny. That was wonderful.
Yeah, I get that a lot. A lot of people ask like, "Why do you go through this trouble?" I find them fun.
It's really cool. I don't know. And then also you're inside of the gazebo environment too. So it's like you want to demonstrate something. I don't know. I think it's awesome.
Yeah, I mean that was one of my frustrations. Like back when I was in college and learning robotics, and it's all like, black and white schematics of robots in a paper in a book that you're reading, and you're like, I don't understand. Like, and the teacher too like has these PowerPoint slides that are very abstract, and you like, and the teacher's trying to tell you how things move, but what if the teacher could just like have the slides there and the robot moving next to it, and they have control over it, and they can, like, the user said, the student asks, oh, what if you moved the robot like this, or what if the conditions were slightly different? They can do it right there. and kind of like, I think it becomes much easier. I'm a very visual learner, so for me that's very useful.
I think that's super cool. I mean, especially like visualizing difficult things like quaternions or something where it's like there's a lot of dimensions. I don't know. It's like a four-dimensional way to describe a three-dimensional thing or for rotation. It's like those are unintuitive. Now let me vary one term at a time and see how the robot arm moves. Like that's super cool.
Yeah, exactly. So
this kind of thing. Yeah, I like that too. I'm a big fan of visual things too because it's you could have students debating this all day about how to like understand these. Like you do this, it does that, and then it's like, or we could just see. You can just run it, and you can see right then.
Exactly. Yeah.
I like that too. Now, one I imagine, or I feel like there's a lot of interest in like machine learning and reinforcement learning, and so I've seen some research papers and things where they're trying to reduce the simulation to reality gap by making the simulation vary more so it doesn't overfit quite as much. And so some of the examples I've seen like this, they'll have a simulated world and they'll just change the texture of like all the objects in the world kind of randomly to try or to all different sets of things so that they can be a little less more about the structure and less about the material maybe. Basically vary what isn't the core part of the task they're trying to do. Does Gazebo do anything for, or how would you approach these if you wanted to use Gazebo for like a reinforcement learning context for robotics?
Yeah. So there's a bunch of people using Gazebo for reinforcement learning like this. I think one of the ways that I've personally like generated a lot of like random environments is to write scripts that generate these environments that you're going to load in Gazebo. So you can the environment that Gazebo is loading is just an XML file. So you can make multiple XML files and just load each iteration, each one with that file describes everything. It's called the SD format, and it describes everything from the physical characteristics of your robot, so like the friction or the mass, and also of the objects that are around it. So if you want your robot to interact with, like, pick up different objects, you can like vary their mass and their dimensions, and also like the lighting and textures, like you mentioned. You can describe everything there. So one approach is to just generate several permutations of these worlds, and then you load them into the simulator, and you train your machine learning algorithm. One thing that is coming up new with Garden now is a reset interface for Gazebo. So because yeah, like what I just explained is a little bit time consuming because you have to shut down the simulator and load a new world from scratch every time. So now we have a reset interface where programmatically you can write a little script that says run the initial world, you have it, and then reset, go back to time 0 and modify just this little thing. You can write this in a C++ plugin. And you can say exactly what you want to change, and then run the simulation again, spit out some results to your preferred machine learning platform, and then reset the simulator again. So it's much faster because you're not like shutting down the process, opening the simulator again, loading that large XML file. You're just changing things programmatically. So from Garden, now we have this interface there.
That probably speeds it up a lot. Yeah, I don't know. I've been working with Gazebo Classic in this quite a bit for, yeah. But so
I'm familiar with the project.
Yeah. So I'll have to do parameter tuning or something like this, and so I'll run it with one set of run the simulation with one set, evaluate, run it, this kind of thing, and it's much slower, but it's running a huge system on the back. It's for a NASA project, but it's a painful process. And so the idea of and we're trying to figure out how to keep the simulator up, but it breaks all sorts of physics stuff. Probably not on the Gazebo side of things, but I don't know. I'm not terribly knowledgeable, but
Gazebo Classic also has a reset interface that could be used there for you to restart things. But yeah, like you said, the simulator is just one part of a bigger system, right? And you often have controllers and other things that in the like. When people usually create a robot for the first time and they write those controllers, they don't write controllers that you can go back in time or, reset. And then when you're starting to try to bring these things to simulation and do more complex things, when it comes down to time or the state that is held inside that, everything breaks apart. So, yeah.
So with this, is there also the ability to run it without run Gazebo without the display or without the GUI? So if I want to run it headless.
Yes, you can. Everything is modular. Everything is optional. So you can run just the server, like just without a graphical interface, just on the cloud or in your local machine. You can even run without loading any rendering engine. Like if you're not simulating cameras, if you're just simulating like IMUs or GPS and things like this, or you can even choose not to use a GPU. You can use like the rendering on your CPU. There's a mode for that if you're trying to use a machine that is not very powerful and that doesn't have very expensive hardware. It's going to be a little bit slower, but this is what people use a lot for doing learning on the cloud, right? Because you don't cloud machines with GPUs are very expensive. So if you can do the rendering, even if it takes a little bit longer on the CPU, it's much cheaper. To run like thousands of simulations to do parameter sweeps or machine learning and all of that.
All sorts of things. That's exciting that it can run really well, headless, no GUI, this kind of thing. I like that. I really like how modular it is. What about, you mentioned that for the Gazebo Classic, when you were working with that, you were writing JavaScript and it was like web-based and this kind of thing. Does current Gazebo, have any sort of web interface or?
Yeah, it's a lot of the work that I did back for Gazebo Classic is being reused. So we have what's called GZ Web also for the new Gazebo, and it's the same thing, right? Like you can run just the server of the simulation that is doing the physics and the sensor data generation, and then for the user, you can choose to load the native UI that is written in C++, that opens like a window on your computer, or you can choose to just load it on a browser. And the browser one has less features, but if you're just wanting to peek into your robot, see what it's doing, it's plenty good for that. Yeah. Yeah, you have like machines that you're training on the cloud, and you want to take a look into what's the current state, or why is this one does this one keep failing, and you just want to look, like seeing the logs sometimes is not very nice. You just want to take a peek on your phone, and you can just take a look at that. Yeah.
That's so cool. Yeah, the portability of the web is amazing for that. Like look on your phone, this kind of thing.
Yeah, because you just write for the browser, and then you can run on Mac, Windows, Linux. It's
Hmm. What was the decision to have the majority of the GUI in C++, as opposed to web because of that flexibility and portability? I imagine that there's pretty significant reasons to not do everything in web if you guys moved away from web, in spite of the huge win with portability.
Yeah, we still develop first for the native UI. We do have the web UI, but that doesn't have that's not the main focus. I think that we'd had this discussion back when we were in the beginnings of the new Gazebo. Like, should we just drop the native UI and go full web? And there are certain things that people want to do, like especially when it comes to visualization. Like rendering fidelity that at the time weren't as good in the web. I think that the web has moved along a lot, and there's like you can probably do very similar things that you would do on the native app on your browser, but the browser tends to always be a little bit slower, especially like if you have huge environments that your robot is interacting with, and you want to visualize them very nicely. The web can be a little bit slower. So that's why we focus on the native stuff.
Gotcha. So primarily performance reasons are why you have the native C++. That's like one of the large reasons.
Yeah, I think that's one of the large reasons, and it also makes the user experience a little bit better because you launch one thing. You're always going to have to launch the simulator itself on the back, right? Like you don't want your physics running on your browser, or or like 20 robots, each one with 30 cameras, all of this being rendered by your browser. So you're always going to need that native application that is more powerful. And then if you just can launch a user interface together with that, it's all there in one. Otherwise, if you have a browser, you have to open the browser as well. And so you have two things to launch, and then you have to make sure that they are connected. Maybe they are not talking through the same WebSocket, and you have extra configuration. So it can be a little bit more troublesome. I don't think it's a lot of trouble, but it's one thing to consider.
Yeah, for sure. And yeah, I think you probably don't want a physics engine running in your web browser. I feel like that would just eat resources. And I don't know that there is even, I'm not aware if there is a good physics engine that would compare to like Dart or Bullet or I don't know, ODE or any of these other ones.
I'm aware of a few projects of physics engines that run on the browser. That's something that I've always wanted to, like, what if we can get rid of the native C++ application completely and just run the entire simulator on your browser, right? Like, I think that there's a future where this is probably going to be possible. Right now, you're not going to get a lot of performance out of that. Maybe for simple, if you just have a simulated arm,
huge environment with a complex robot and complex interactions between a lot of actors in there.
yeah,
Gotcha.
that's still tough.
What do you think are some of the what are some of the bottlenecks that are stopping us from that idea? Like, where do you think it's most tough? It's just performance, or are there like other things that need to come and be before that is possible?
I would say it's performance. One general bottleneck with physics in general is being able to parallelize things. You can with rendering, you can kind of like isolate each ray of light and send each one to like a processor, and they're processed independently. They don't interfere with each other, and then you just show that final image as one thing, but it was calculated all differently. With physics, because of the interactions between bodies, it's if you have a lot of, like, for example, two humanoid robots with a lot of joints, like touching each other and interacting with each other, interacting with the environment, maybe there's like a lot of movable objects around, you have to simulate that all as one thing, because the movement of one thing is going to interfere the other things. It's very hard to parallelize it. I'm not familiar with the latest like academic work, but I know that there are people trying to doing research actively to parallelize more and more of physics, and I think this will be possible in the future. But right now, I think this is the biggest bottleneck, just parallelizing all of that confusion. If you have robots that are independent, like each one in their corner, they're not going to touch each other. You can simulate them separately, and Gazebo supports that. You can break them apart in separate processes and even in separate cloud machines and simulate them separately. Yeah, but you have to choose carefully, because if they ever come close to each other, they're just going to go through because they don't see each other. Yeah, they're separate things. They just happen to
They're
be
like
there.
ghosts, two ghosts that are totally
Yeah,
unrelated.
yeah,
Uh,
yeah.
well, that's very cool. What do you think? What are some hard challenges in simulation in general, in your opinion?
Um, well, I think that it's the like how close to reality do you want to get, and what are you really trying to get out of simulation? I think that a lot of people struggle with simulation because they come with this idea that I want it to be as realistic as possible, and then they end up with simulating a lot of phenomena that don't affect the final result of what they are doing. So just like making it customizable in a way that is understandable for the new user, like, oh, I what I'm really interested in is the high level behavior of how multiple robots work together. I don't care about the individual joints in each one of them. I don't care about, choosing the right level of detail for the phenomena that you're, like the questions that you're trying to answer with simulation, right? That I think is hard. It requires a lot of iterations, creating simulations to get to the right balance, if you ever get to it. So I think that if a simulator can make that easier for people to tune, that's going to be a huge game changer, because people were really going to say, well, what I'm really interested in right now is like how this robot behaves when it crashes with this like wall, and how it recovers from that or something. And I don't care about any other phenomena. How can I turn them all off, still have a meaningful simulation that gives me the answers that I'm looking for?
Hmm. Yeah, and you mentioned earlier, oh, having a wizard. Do you think this wizard will go towards that, where it's like you ask the user, like, all right, are you just caring about mobile robots and their interactions? Are you just caring about interactions with the terrain? If it's like a legged robot, are you just caring about like what the things, and then you can turn off a bunch of things depending on that, or turn on a few others, or
Yeah, I think I can definitely see a wizard being a solution to that. Right now, it would just be very difficult to make it power easy enough, and yet general enough to for anyone with any robotics problem to come and be able to just choose a few settings and have at least something to start from. So what we have with the quick start dialogue is we have at least, like, you have an example of a self-driving car, you have an example of a drone, you have an example of a humanoid, and you can extrapolate from that to your application. But within self-driving cars, there are so many different things that you may be wanting to do, right? And drones, like there are drones that are fixed wing, drones that are quadcopters, hexacopters, and then each one of them you have to customize differently, right?
for sure. And even still, it's like big ones, small ones, like their dynamics change a little bit. It's like all sorts of things.
Yeah, and that's just a robot. Then there's the entire world around it.
Uh huh. Gotcha. Any other really hard problems that you can imagine? So, getting basically the last one, if I understand correctly, is optimizing for someone's specific use case. So they are going, I'm simulating this and trying to kind of suss out what's actually important for the simulation so that you can run it really well, but not simulate a bunch of other things. And that's probably very important in like a machine learning context or something that's going to be computationally expensive and wants to run a whole bunch. Any other things that are gonna like really hard in simulation?
Yeah, the general, like, tuning the simulation to really reflect your your real robot and your real scenarios, and generating random, like, various generic scenarios that are realistic that your robot can interact with. all of that content creation is hard. Like you often need like artists that are like 3D artists that are very skilled at texturing things right, making the meshes with the right level of detail, that it's not too detailed, but it's detailed enough for the robot to get the meaningful characteristics that it wants to get from it, um, organizing the lighting properly and all of that.
Yeah, for sure. What do you think about contact forces as a challenge? So, like if I'm trying to manipulate things, or I don't know. At some point, I wrote a rigid body simulator and multiple contact forces. Like if you have, say, feet that have like a few points of contact, like that's really challenging. Or if you want to pick up something small and be very accurate, like simulate picking up a screw or something like this. How do you think of this, or am I wrong that this is not this? Is this a simple problem, or how do you?
No, I don't think it's a simple problem. It goes very down deep into the physics and into the like the time step of the simulation that you want to simulate, right? You don't want to be simulating every nanosecond to really be able to give every detailed interaction, but you also don't want to be simulating just every second, right? Because then things go through each other. So yeah, in the physics itself, there's so much different phenomena. Like there's soft bodies, right, that you want to interact. Like Gazebo uses a lot, like pretty much exclusively rigid body dynamics. So the assumptions there is that things, if they deform, it's just very little
It's on joints, basically, right?
its own joints. There is like on Gazebo Classic, there we did a lot of work on like adding certain parameters so things could penetrate a little bit into each other. So you do have a little bit of bounciness, a little bit of compliance there, and a lot of that has been ported to the new Gazebo already. But that's only like that's not deformable bodies, right? Yeah, there's so much that you can do with physics. You're always gonna have to choose a level of fidelity that you want, right? And that's necessary for you. But definitely, like manipulating things in simulation is notoriously hard.
Yes, for sure. Yeah, like you take, I don't know, it's a flexible object, and then now you make it wet, or then now you make it filled with like one of those I don't know, squishy kids toys that's like it's flexible and full of like liquid, and the liquid can slosh back from side to side. It's like now simulate that. It's like three things that are difficult: the wet, the liquid sloshing back, so like the inertia is changing, and then not rigid. This kind of thing.
Yeah, and simulate that as fast as you can, faster than real time. Yeah.
Yeah, faster than real time, please. How does Gazebo do with reasonable, like in terms of or relative to real time? How does Gazebo do for different sizes of simulations?
It really depends on how your simulation is designed, what it's doing. That's what I'm saying. That like it's so varied. You can have simulations running like thousands of times real time. In the new Gazebo, we have that. Like if you don't have a lot of heavy sensors, you just have like pretty much the robot moving around and collecting some data and receiving some commands. You can run super fast. And then as you start adding sensors, and if you want like high definition cameras, everything adds to it, and it gets slower, 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 and you can easily end up with a simulation that is much slower than real time. So it really depends on what you're trying to get out of the simulation and whether it's set up correctly.
Yeah, I feel like this is one area where it's like, or simulation in general, it's like you need the wizard or something. You need like a simulation expert next to you when you're trying to make your problem. And like the wizard ideally should be able to do that or some tool, but you need an expert.
Ideally, I think eventually we're gonna get rid of the expert, right? Like eventually it's gonna be as easy as creating a PowerPoint. You don't need someone that knows computer graphics to place images, and like everybody can kind of do it, and you can. Sure, you can't do like very complex or beautiful images or whatever, but everybody has the basic tools to do something that is functional and is good enough. And I simulation is very far from that. Robot simulation is very far from that right now. You really need specialized knowledge. It is a very it's something that not everybody's doing, right? Like way less people are simulating robots than creating PowerPoint presentations. So,
Yeah, what an
yeah.
understatement too.
Yeah, yeah, for sure.
uh, uh how do you think of simulation and physical robots working together?
Yeah, that's a like there's hardware in the loop simulation where you can mix like aspects of the physical robot. Like you have the hardware there and you make it believe that it is somewhere and you see how it moves and you actually are exercising the real controllers and the real actuators and sensors. So, well, sometimes the sensors, all the data is being fed from the simulation, and that's very valuable, right? For you to get very much closer to your final product, your final physical robot.
Probably helps you iterate significantly because you can test that the behavior seems right in situations you set up with data, realistic data coming from the sensors and this kind of thing. So I could imagine that as being really valuable.
Yeah, yeah, and like most robot simulation is created with the goal of eventually using like doing a physical robot, right? Like there are people who do simulation just for the sake of simulation. They're trying something new. That happens, right? But that's the minority of cases. Most people want to eventually get to that physical robot. So it's very important for you to design your simulation in a way that you're not cutting corners or you're trying to you're really trying to reproduce what you have in the physical robot as much as possible in the simulator and reuse as much of the code that you use for the physical robot in the simulation. So when you want to make the switch, you just plug a switch and that your controllers and your algorithms don't even know if you're in simulation or in a physical robot, right? Like they just behave the same way.
Definitely. That's a funny way to phrase it. They don't even know. They're just, yeah, they get the inputs, they do their outputs, and it's the same. That's so funny. Uh huh. Switching just, or switching tone a little bit with this, how do you, or what have you learned from your perspective, or like, what are some major things that you've learned by being the tech lead on the Gazebo project for so long? Like, I don't know, what are some of the big things you feel like you've gained over this whole process?
Well, that's let me think a little. So specifically about leading a project, not just in general working on the
Just
project,
in
right?
general, like how to organize things, how to interface with the community, whatever kind of sticks out to you.
Yeah. Oh, well, I learn a lot from the Ross community actually because they are very connected communities, the Gazebo and the Ross communities, but they do have a certain degree of separation, right? There are many people who use Gazebo without Ross. And so as tech lead during these past few years, I've been trying to build up a little bit more of a community for Gazebo. Like we have our monthly community meetings open to everybody, and we post them to YouTube. We just had one this morning, and like just making sure that all of our development is very open. Like all of our development processes are posted so we can get anyone on the internet who wants to contribute to Gazebo, they should be able to find all of the resources because we don't like everything that can be public at Open Robotics, we make it public by default. So I've been really trying to make sure that everything is documented, everything that can be automated is automated. So a lot of our CI, like continuous integration, right? The testing for the simulator, all of that is as automated as it can be. All of our development processes are as automated as we managed to make them so far. Like there's much more room for automation. There's a lot of little things that we still do manually that we could do better, and I think that it's been this continuous improvement. So for me, for learning, everything has been new things that I learned. For example, I've been touching infrastructure way more than I thought I would. As you know, I before being the lead, I was one of the developers in the team. I was mainly doing C++ development for features for the simulator, but nowadays I'm very deeply involved in releases and making sure that the versions of various libraries work well together, that our pull request system is working and you can merge a pull request that spans across different libraries. All of those little infrastructure things I ended up having to touch a lot more than before, which I enjoy. It's fun stuff to do. Um, but yeah, there's probably a lot of other learnings too, like dealing with people, dealing with the community, being the face of Gazebo. Often like has been a lot of fun.
Yeah, for sure. Yeah, being the face of anything, I suppose, is pretty interesting. People will come to you and they associate you with it, and you get all the problems and all the wins probably too.
Yes, oh my God, there's quite a lot of that, right? In open source, yeah, there's a lot of users who just take for granted all of the work that goes behind making sure that the software is delivered to them for free in a timely manner, in a with quality. It's something that they're not paying for, and often people forget this when they come with their complaints and requests.
Yeah, for sure. Yeah, that's a tough thing. Why? So I know that that's like one of the downsides with open source. Some people take your work for granted and everything. And I know we're both biased because clearly we're at an open source company. But why open source to you? Why make it all freely available?
I think like it's so valuable to have other people looking at your code. Like we get contributions from people who are not in the core team that really improve Gazebo considerably. Gazebo and ROS, right? Like what would ROS be if it was a closed source thing? It wouldn't exist, right? Like the entire ecosystem around it is made of people like outside of the core development team. And also like the way that it empowers people, especially like the things that we develop are things that people are studying in college and they are trying to learn, and it's tools that they use for their own learning, and it's great that they can have them available for free. Otherwise, it wouldn't be accessible to a whole lot of people if it was charged. So I think it's only good things from open source. Of course, there is a little bit stress here and there, but I'm sure that there's a stress in everything that you do. So
Yeah, it's all trade offs. Gotcha. And so sad to say, you are leaving Open Robotics, and probably by the time this interview airs, you will be gone. But can you talk a bit about what you're doing and where you're going?
yeah, sure. Yeah, this is I have 3 days left. We're in the middle of right now the garden release. I want to leave things in the best place possible before I leave. But I'm not abandoning Gazebo or anything like this. I plan to stick around. I'm just going to be an external member of the community, doing it on my free time whenever I can. But yeah, it's been a long run, 9 years with Open Robotics. It was my first job out of college, and I feel like at this point, it's important for my career that I experience different things. I'm also looking forward to working with an actual robotic product that is being shipped, and it's the final product, because my entire career at Open Robotics, we work on the tools that other people use to make their own robots, and they get all the glory. And then it's like, oh, they used Gazebo to develop that, but like Gazebo is just one tool in their arsenal, right? And now I'm going to Zipline, which is a company here in the Bay Area, but they are deploying like drones that deliver blood and other medical supplies in various places in the world. Like they started in Africa, but they're in many countries right now, and it's running right now. It's a real application. They like it's not just a startup with a crazy idea, right? Like they are doing it right now, and being a part of that is very exciting to me. Like the mission, and it's very similar to how I feel good about my work at Open Robotics, doing open source, doing this thing free for the world. I'm feeling very nicely about going to Zipline as well, because it has this whole doing good aspect to it. So looking forward to it. Yeah.
Yeah, for sure. Yeah, donate or flying blood, medicine, these kinds of things to people when they need it, in especially like rural places where it might be difficult to drive a car. Like that seems it seems like a very humanitarian cause, which seems excellent to me.
Yeah, yeah. And it's like for me, it's an excellent use of robots, right? Like it's really solving a problem that couldn't be solved otherwise. Like having a car or a motorcycle in certain places is much slower. It's worse for the environment to go and deliver these things that you need very quickly. So yeah, yeah. And the way that they are delivering things very fast, on demand, it's really a very good use of robotics, I think.
Yeah. From your perspective, does it seem like so you're going from kind of building the tools for everyone else to now you'll be working with a physical robot, actually doing something? Does it feel like kind of the next stage of your career or this kind of thing? Like you, I don't know, like the next place that you want to grow to?
Yeah, definitely. Yeah, I'm looking forward to really, um, being very close to the final product. At Open Robotics, we interact a lot with clients, and we are very close to their problems that they're having with their robots and the things that they are trying to solve and the applications that they are trying to ship. But we are always like that other company that is just helping a little bit, and then the project ends, they go on to do their things. So it feels a little bit like that, like the next step. Yeah.
Hmm. Yeah, it's very exciting. And you're going as you'll be the head of simulation, correct? Or
Yeah, that's it. So I'll still be working on tools. I'm not gonna be there like the one like putting the robots together or anything like this, but it will be very focused on like the problems that we have right now that we have to solve for in the real world. We have these robots flying, and we have legislators that need
oh, zones
like
around things and whatever.
yeah. So
Can't
we
go this
have.
close to an airport, this kind of thing.
Exactly, yeah, and things for like for certification, right? Like how do you prove that your robot behaves well in a variety of scenarios? All of those things, simulation can be very helpful for. So I think I'm gonna be much closer to the final application and the final problems that you have when you're shipping a product.
Hmm. Do you do you anticipate you'll be using Gazebo?
No, I don't think so. They have another simulator.
Ah,
Yeah, yeah,
yeah. Couldn't bring your baby
yeah.
with you in a sense. Yeah,
Yeah. But yeah, I'm looking forward. Like I'm starting next week, so I haven't seen it in action, but I'm looking forward to learning more about it. Yeah.
for sure. Very interesting. Do you think I wonder. So, as the head of simulation, you'll probably be leading, well, the simulation efforts and this kind of thing. What what do you think you're gonna do differently than what you did with Gazebo, kind of on a pragmatic level with this team? Like, given what you've learned, what will you change?
I think it will be completely different because being an internal tool, it doesn't have that thing that Gazebo has of being the generic simulator that needs to do everything, right? It just needs to simulate some specific robot, in a specific type of scenario. So we can be much more focused with the development and really make sure that the tool works well for that use case. And I think also the number of stakeholders is going to be very different because right now with Gazebo, like even inside of Open Robotics, we have dozens of clients all wanting different things from Gazebo, pulling from different sides, and we have the community, and one wants this, one wants this, and it's a lot of different stakeholders there. And I think that there is going to be like a few different teams that are using simulation for their own purposes. But I think it's going to be much more focused and much more, everybody's more aligned with one goal, right? So it's going to be different for sure, very different. There's no like the open source aspect to it of like or like making releases for people that you don't know who may be using a random version of like Linux that they needed supported, and they may be broken in ways that you didn't anticipate, which is a big concern with Gazebo. I think you can move a little bit faster if your user base is much smaller.
Yep. you can enforce kind of like a uniform platform and everything else too, which is really because it's a small number of users, well-funded company, these kinds of things. Yeah, that will be very different. It's interesting. It's like so being at Open Robotics, it's kind of like you're satisfying a lot of things. You're working with a lot of users, and you've kind of learned a whole bunch. And then you get to go, and now you found an application. This application is very interesting, and you get to go focus and like go really deep with that, move very fast with that. Take all the lessons you've learned over this time. That seems very exciting to me.
Yeah, yeah, I'm very excited. I mean, it's bittersweet because I really enjoy my current job at Open Robotics. I really enjoy like everything, the team and the community and the software itself. And but at the same time, like there's only one life that we live, and so many different things to experience. So
Yeah, for sure. Let's see. Getting into more like an advice related things. So for someone seeing this, thinking simulation sounds really interesting, wanting to know how to get started, where do they start?
use Gazebo, download it and try it.
You'll still
Well,
evangelize it.
yeah, yeah, yeah. Well, it really depends on what you want to do, right? Like if you just want to, like simulation is great if you don't have a physical robot. Like you can, right now, you just need a computer and you can be immediately playing with like very cool robots that other people are developing, even though you don't, and it's completely free, right? Like you don't need to have them physically in front of you to play with them, try different algorithms, try different things. So it's very good for learning in this aspect. So if you want to get more into not necessarily simulation, like into robotics in general, you're probably going to touch a simulator first before touching a physical robot. Depending on what you're doing, like you could get a cheap robot at
Or
home,
if you're at a
and
university or something,
yeah,
you may
yeah. If you have
understand,
access to
but probably not
hardware,
everyone.
yeah, but the most accessible, especially if you're talking about like robots that cost millions of dollars, the most accessible one is definitely a simulated one. So think of the domain that you want and look for an existing simulation of it out there. Start poking around, start modifying it, customizing it, trying different controllers, different algorithms. Just poke around and see how you can make things more interesting, I think.
Hmm. How does anyone? So if someone is starting off totally fresh, how do they like? Are there any good tutorials? Is there any good way to like really understand what's going on and I don't know, just like hacking and trying different things is definitely one thing, and it's a very valuable way to learn. But like, if I'm starting anything new, like when I started learning computer vision for the first time, I tried hacking, and that was my first approach. But I totally missed the global picture. And then I took a university course, and it was like, oh my gosh, like this has been so much more valuable. But then all the hacking, now I have direction when I hack because I understand the bigger picture. How would one get the bigger picture for this?
Of simulations, like you're talking about someone who is interested in developing a simulator or someone who is interested in using a simulator as a tool to learn robotics in general, right? They're different things. So it would be the second,
The
I
second one.
guess.
Yeah,
Yeah.
learning robotics through simulation, probably.
Yeah. So, like, one thing about Gazebo that is a little bit intimidating for some beginners is that it works better on Linux. So you would have to start from a Linux machine. It does work a little bit on Mac OS and parts of it work on Windows, but I wouldn't recommend it for a beginner because you need to jump through. Yeah. Yeah. So the easiest path is definitely starting with an Ubuntu machine, a Linux machine, and then going through the installation tutorial, which should be straightforward. You run a few commands on a terminal, and you can launch that simulator. And now that we have the quick start dialog, when you launch Gazebo for the first time, it's going to show you a few different worlds that you can poke around. And it's cool that we designed those worlds in a way that you can immediately see the robot moving. So, for example, if you choose the drone and you click on it, it's a drone in a world that is full of clouds. They are clouds. They're not asteroids. Something like, yeah. For the record, they're blue. They're clouds. So it was made very quickly, but it shows like that where the drone is, and you have controls right there on the graphical interface, and you can start flying the drone, and you can start sending commands and seeing how the drone behaves and where it goes, and then from then you can start poking around a little bit more, or you can start to, okay, I saw that a drone works. Close Gazebo, open it again, and try the self-driving car now. Also, there are controls on the UI, so you can drive the car. It's kind of like a 90s video game. You can. It's a real. The model in that world is a real race way that is here in California. So it's a very realistic, and it has a Prius car. So it's also a real car that exists, and you can drive it. And there are no points being scored. It's not a video game, but you can imagine that, you complete a lap and you feel happy about yourself. Then you see how that's working. You can see like the various cameras that are attached to the robot. They're right there on the UI. So we made it in a way that even if you are not comfortable with the terminal running commands or hacking around, you can still get a sense of what the simulator can do from the user interface. There is a humanoid, and you can like slide its joints, so you can see like the arms moving and things like that.
Cool. What if you wanted to start pushing into robot algorithms, like say you want to do A star for navigation or SLAM for generating a map and this kind of thing? Any way to like, because to me this is cycling from like very intro to like more of an intermediate level. To me there seems like a big gap there. Any advice there?
That's so definitely you would start with ROS there, right? Like you would leverage all of the algorithms that people have already implemented for you with ROS. Same thing, it works best on Ubuntu. You would start from an Ubuntu machine, run a few like installation instructions, and then, for example, you can try the dev stack. They come with a bunch of demos. I think that at this date they're still using Gazebo Classic, but they're in the process of migrating to the new Gazebo. But you would launch, a turtlebot or a simple like ground vehicle in a world, and have all of the navigation running there for you. It's probably going to launch RViz, which is Ross's visualization, and you can put a goal for where your robot is going to go. And once you send that goal, the robot is going to move in the simulation, and from then on you can start poking around. Well, like what happens when I send the goal? Oh, it's sending a ROS message, and you start figuring out from there. Yeah. I enjoy this way of learning, of starting seeing something happening, and then you deconstruct it in the way that you find more interesting. Some people may be more interested in the, how is the robot moving? Some people may be more interested in the A-star algorithm itself. But other people prefer to learn the basics, right? Like, what is a publisher? What is a subscriber? And then eventually, 5 years later, you can get to the whole running thing. I like the construction approach, but I think it's different approaches that, depends on what you like best.
Bottom up or top down kind of thing. Mm-hmm. Let's see. And then kind of big picture, what do you think, or where do you think robotics is going in the next 2 to 5 years?
2 to 5. That's very soon. Yeah, it's hard to tell. There's a lot, obviously happening in like self-driving cars and all of that stuff. I really don't think that it's the 2 to 5 year time frame that we're gonna be everybody like with their self-driving cars. Yeah, I think it's after that for sure. Yeah, it's a hard problem, and I think some companies are trying to rush it, to win the race. So, and you have people's lives in your hands, right? Like, so you have to proceed with caution. But yeah, there's a lot of cool stuff happening, like in agriculture, in even in factories. Like robots have been in factories since forever, and they are more and more gaining space and doing more various things there. like robots in space, right? Like, robots have been to Mars, multiple robots. No human has been there yet, and we're sending more and more in the coming years. So that's also exciting. Yeah, like lots of underwater robotics is like, at least the people who have been using Gazebo, a lot of people are using it for underwater robotics. So people collecting data or like from the ocean, and just like deploying these like fleets of robots to just Ben, yeah, we worked together on that, on the simulation for their underwater vehicle. So it's, yeah, there's so many domains. Robotics is really huge. So
Do you think it'll start to flourish in these areas, or just start to become more and more useful over time? Or it'll stay more similar, or what do you think? Closer to what it is, or?
uh, yeah, I think, yeah, it's slowly. I don't think, it would be really cool if something comes up, out of the blue, like very game changing. Like, it's hard to know that these things are coming, right? Like, all I can think of is the iterative, like the robots getting more autonomous and more useful and more usable, and little by little, yeah. But I wouldn't be surprised if like little changes come, like there's like a new Roomba, right? Like that is suddenly in everybody's homes doing a task that we all hate doing manually, and it's gonna be doing for us.
The thing that I found really interesting from a very recent interview, and I've seen this a few times, but kind of the pattern is sticking out to me. Robots in unstructured environments, not like factories, or even like in a warehouse setting, but still unstructured, people are around, there's exceptions all the time to what they expect, are starting to be very valuable. This is probably the first time that I've seen it. Like a robot will justify its purchase price in 2 to 6 months for this kind of thing and automate, which is unbelievable to me. This feels like a tipping point to me. And I've seen a few examples of this, but I feel like this is going to be happening more and more and more going forward. In the past, it was a very long time before robots could justify their purchase price. So that's the very exciting thing that I'm seeing. But I don't know. That could make it so there's a lot more robots out there, but I don't know the timeline for this kind of thing.
Yeah, you're, with the exposure that you have and talking to various people, I think you're in a better position to answer that question than I am. I know what people are simulating. Yeah.
So wrapping up, do you have any links, contact info, anything you'd like to share with our watchers and listeners?
Yeah, so like by the time people are watching this, Gazebo Garden is gonna be out. So I definitely recommend that you check it out, try out the new features, try out the new demo worlds that the team is currently putting together. With we always put together a demo world for our releases. So that one is this time it's gonna have the moon. It's gonna have some nice rendering effects to show the shaders and all of that stuff. So definitely try out Gazebo. Just Google for it, and you can land on the correct pages at gazebosim.org. Um, and yeah, I think that's the entry point for people who want to learn more about all of the stuff we've been talking about.
Awesome. All right. Thank you, Louise. I'm going to miss you at Open Robotics, and good luck in your next endeavor.
Thank you, Audrow. This has been fun. Yeah.
All right. Bye, everyone.